Good morning. If people have questions while I'm talking, please raise your hands and interrupt me. I actually prefer things that are done that way. And if I don't get through everything in 20 minutes, then that's fine with me. What I want to talk to you about is ROX. And for those of you who don't know what ROX is, I'll do a quick introduction to it and some of the the very highest level features and what we look to accomplish in ROX. And then I'll describe porting ROX from its Linux-based environment to Solaris and where we are in that process. It's not complete, but we've actually made very good progress over the last year. And of the people who you see on this list, the person who's done most of the work for ROX on Solaris has been Anup Rajendra, who's down there, and he's raising his hand, and he's been working hand in hand with two Sun engineers, Craig Winters and Dale Layfield, and they're also just sitting over there. So if you have real detailed questions about where things are working and where problems are, I'm just the pitch man. He's the guy. Those are the guys that are doing all the work. So let's talk about ROX started as a software project about 7 years ago, and just looking at a traditional, trying to build software for traditional clusters. We sort of looked at the cluster problem and said it's really too difficult to build systems of various scales. And so this is what your standard cluster looks like. There's usually a front end with some private Ethernet network and maybe an enhanced network. Perhaps we'll see network convergence with InfiniBand over the next few years. I wouldn't want to make that prediction or not make that prediction, but this is what things look like. And then you had a whole bunch of computing nodes, and all those nodes look the same. And the standard way of provisioning this thing was that you sent somebody off into a corner who knew how to build or knew how to install all the HPC-specific applications, and they built their golden image, and that was cloned on every single one of your nodes. And as long as you had the same hardware, you wanted those nodes to do precisely the same thing, you were fat, dumb, and happy, right? But things are a little bit more complicated these days. So in sort of a modern clustered architecture. So this is actually the block diagram of production metagenomics server, which has 128 nodes of compute and some database and some portals and some other things that are sitting there. And the pieces that you just see over here on the right-hand side in red, that's the standard Beowulf computing cluster, right? It's one little piece, and it's actually, of all the things that we do, is actually the simplest in this particular project. So ROX is about how do you build things that look like this, and there'll be a larger picture, but if you look down here in the corner, there's 7 racks of equipment there. One is for switching. One rack has 200 terabytes of thumper-based storage, and there's 128 generic Intel-based computing nodes, and then there's another rack of database servers and portals and kind of all the catch-all stuff that you need to make things work. But there are other kind of clusters that are out there that ROX also handles just in exactly the same way. So they're visualization clusters. If you go to the SDSC booth, you'll see one. If you go to the NCR booth, you'll see one. If you go to Sun booth, you'll see one. If you go to the AIST booth, you'll see one. All of these things, they're just clusters, and many of them run ROX, and we provision them in exactly the same way we would build a standard computing cluster. So the goal of ROX itself as a software project, it's open source. People can download it. Thousands of people have built clusters with ROX. This is, it's somewhere between an academic curiosity and something that's commercial. It's in this kind of space that just as a project all by itself, you probably wouldn't generate enough commercial revenue to do it, but it's part and parcel of what people need to make things happen. But our goal has always been to enable domain scientists to go purchase hardware, build a cluster, build it in their lab, and use it for their applications, right? And not have to go hire a full-time staff member or graduate student to run their 32-node to 128-node cluster, or larger if they wanted to. But there's a key observation for ROX is that because of these different kinds of clusters and different things we need to be able to provision, it handles much more than just MPI HPC clusters. Again, that's actually the simplest stack that we have to manage these days. And it's not a simple stack. It's just the simplest of all the ones of what we do. So ROX itself, it's been 6+ years. We should be saying 7 now because our first release was at SC 2000. It was a very cranky, clunky release of software, but it was out there for people to work with, and we've had many releases, averaging about 2 a year since then. It's Red Hat Enterprise 4 compatible. That means it runs on CentOS, it runs on Scientific Linux, and a variety of other things. But it's important to look at it's Red Hat Enterprise Linux. So the ROX on Solaris is, for us, how do we remove that dependency of ROX on Red Hat and be able to do other interesting operating systems? And for me personally, I don't consider another variant of Linux to be another interesting operating system. Solaris is most definitely an interesting operating system. We also wrote an SDCI proposal, and we're funded from the NSF to continue our development through 2010. So we have some things that guide us, and as we're doing software, is that even when there are hardware changes, whatever you do must be reproducible at the system level. It's like trying to bring some idea of the scientific method back into how you build your large-scale systems. We also look at clusters and say, well, there's different kinds of appliances. There are compute appliances, there's storage servers, there's web servers, there's portal backends, there's any number of little small things that you want to be able to build. And in reality, all of these nodes actually share a great deal of common configuration when you look down at the operating system itself. So we want to be able to do that in a reasonable way. And images themselves don't exist in ROX. We go all the way down to building every system from the ground up, where we just install packages and then configure, but that entire process is automated and it's scalable to at least 1,000 nodes that we've tested ourselves. And for us, we've always had this mantra that if you can be fast, you can be simple. You should really read that, but it's not printed there. If you can be fast, you can be stupid. We like to say we're stupid, or if you're fast, you can be lazy. So we're fast and lazy or fast and stupid, but any one of those things. So what does ROX solve? You're trying to build X kind of cluster or a set of X kinds of clusters. What software should you select? How should it be configured? How long will it be before I start useful work is a key metric for us in ROX. We think that when you bring your hardware in, that if you spent more than a day from the time that you've looked at the nodes and started playing with them to the time you can start doing useful work, you've spent 4 to 5 hours too long not doing useful work. So the idea is you bring it in, you get it running, generally faster than your Windows laptop, for example, right? And then if somebody asks a question, I like your cluster configuration, but my favorite hardware vendor isn't Sun, it's somebody else, but I want to reproduce what you do. Can I do that? And so we help that. And then finally, for the lazy part of us, we'd rather drink coffee than actually configure software. So in ROX, software installation is a first-class thing, right? And there's some realities about it. When you want to build a large system, any system, you have to install software in the first place. If you make that fast and not to the point of, oh my God, I lost my node or I lost something, then you don't have to go through these backflips of carefully hand configuring something and then taking a golden image and putting it over on a CD and sending it across the country so that it doesn't get destroyed. You can look at it in a different way. So we have descriptive information. There's a lot of work that goes on in ROX, and we call this our configuration graph. And we have, on the left side, we have the software distribution of all possible packages. So it's a Red Hat distribution, or it's a CentOS distribution, or it's a Solaris package distribution. Those are just the packages that you might install. And then we want to be able to have this mechanism of generating the descriptive file for a particular node, right? So it's a compute node, it needs these packages, and then these packages need these configurations. If it's a visualization node, it needs these packages, and those packages need a particular set of configurations. So we generate Kickstart files, or we generate Jumpstart files. Right? This is not our own installer. ROX does a lot of work so that we can ride on top of all the hard work that commercial software OS vendors, they have to be able to install on everything, and we want to ride on top of that. And then depending on what you're integrating, you can integrate these different types of appliances. And scale is, doesn't really matter all that much in terms of rocks. 128 nodes is as easy as one. So it scales well. What do we mean by well? One node about 10 minutes, 128 nodes about 20 minutes. 700 nodes, this was not done by us, this was done by folks in Fermilab. They did 35 minutes for 700 nodes of a wildly heterogeneous collection of nodes. And then we support updating the software distribution at install time. So you don't install like base Windows, for example, and then go apply Service Pack 2. You just kind of take all that stuff and put it in the distribution so that when you build a node, it's up and it's up and patched and on the network first time you build it, and that's done after about 10 minutes. In ROX itself, the core is we extend our description with something called roles. So roles include packages, and they include something called subgraphs, which tell you how your role actually integrates into the cluster. We got an email yesterday from a ROX user, a friend of ours, Roy Dragseth, is in Norway, and they're just moving through, and they had 700 nodes arrive in their machine room last week, and they wanted to get things going. And he says he just installed his new cluster, and he was really impressed with the scalability of the installer. We do some things to help the installer to do a more efficient package loading. It's called the Avalanche installer in ROX, and the numbers that he's putting here is the total number of package requests, so 510,000 plus package requests to install his 700 nodes. And then the number of packages that the actual package bodies were downloaded from the front end, about 10,000. So that's about 2%, right? And where do the rest of the packages get downloaded from? They got downloaded by other nodes within the cluster. So as we were installing, we just sort of seed all these packages into the cluster. And if you're a node, the first thing you ask, you say, I need the kernel package. You ask the front end for a list of nodes that has that current kernel package. It gives you a list, and you go get that package from somebody else, right? So if you looked at this download, it was probably about 700 gigabytes of data that had to get transferred out of packages and down onto individual nodes. And maybe 14 gigabytes had to come, 14 or 15 gigabytes had to come from the front end itself. And it scales, so that installation actually scales very well. So for Kickstart or Jumpstart, we generate the Jumpstart files or the Kickstart files using a CGI. And so the nodes go, they boot up, they make a request, they say, please give me my Kickstart file. I don't know what I'm going to be, a compute node, visualization node, doesn't matter. We have a database that will say, you're going to be a compute node, you're going to be a visualization node, you'll be a database server. And the information gets, the Kickstart file or Jumpstart file gets downloaded. So why do we do it this way? Well, if you pull apart a Kickstart file, a Jumpstart file is basically the same thing. Things are called a little bit differently. The thing on the left side is just sort of set up in the packages, just listing the packages you want to install, about 20% of what needs to happen. The thing on the right-hand side, that's about 80% of the volume of the Kickstart file and is about 99% of the work in actually building a cluster or any node, any kind of node, and is that the configuration localization is the problem to be solved, right? Trying to get images out there and then fixing up images, that's not the problem. It's the configuration problem that you need to keep your eye on. So we have something that's called XML-based Kickstart. It looks something like this. For those of you who've seen ROX talks, you've seen this a lot of times, which is just our configuration graph. The things that are up at the top are appliance entries. So if you say, I want to build a compute node, you enter somewhere in this graph that says compute, and then you just expand the instructions that are in these nodes. These are just text-based nodes. It's packages, and then how you configure those individual packages. The reason why we break it out this way is that if you look at any particular set of nodes, you'll see an incredible amount of configuration sharing. It's just very practical how you do this. So a visualization node looks a lot like a compute node. One runs a scheduling system, as runs an SGE backend and one doesn't. And one has a set of visualization software and one doesn't. And then the rest of it is sort of all the same. It's the graph that you saw is the thing that builds this. This was this production metagenomics complex. You can go to www.camera.calit2.net, and this is the machines. These are the set of machines that you'll hit. This is storage. There's compute nodes, and then these are the catch-all things. We have one person that is responsible for building this entire structure, and he probably spends about 25 or 30% of his time just making sure that things are there and working and dealing with the inevitable failures. So this is not, it's lots of people's expertise, but all bottled up when you want to implement it. It's one person and is done in much less than a day. Let me not go through this particular piece, but I'll take, what we do is that we take a standard software stack and we explode it so that we explode it, and the way we explode it are in these roles. So the roles is software and configuration. And when we want to build something like camera, all the things on the left-hand side down at the bottom are standard ROX roles, and then we have camera-specific localizations that make sense. Again, all captured into a well-defined, almost programmatic stack for how to do this. So now there's ROX on Solaris. So what are our goals for ROX on Solaris? All this works in Linux. It works very, very well in Linux with literally thousands of clusters worldwide that run some version of ROX, but really the basic methodology, depending on your version, the methodology hasn't changed very much in the last few years. Our goal is to build Solaris-based through and through, front end, so that you could build a Solaris-only cluster or a Solaris-only set. You could build camera as a Solaris-based only, or mix Solaris with Linux, right? We know we can do Linux only, so that one's already done. And we want to do it using this graph-based descriptive approach. That's what we need. That's what we want to do, what we need to do. And for us, we want to reduce our dependency of ROX on Red Hat. And we want to get access to some Solaris-specific technologies. ZFS is I've said to many people, it's pure magic. In our thumpers, they run Solaris and they run ZFS. But we don't have the mechanism to manage them. We manage them in the old-fashioned way, and they take much more time than we should. Dtrace, scalability in terms of thread support and that sort of thing are just a few of the things that recommend Solaris as something to be looking at. So the current status, and this is where you really want to talk to Anoop and others to see what's going on, is that we can install Solaris backend, so compute nodes or anything except the front end, your provisioning head, using Jumpstart from a Linux-based front end, right? And we can extend the Jumpstart installation using ROX and building roles. These graph files, so roles make up, when you look at the configuration graph, there are different colored elements in the particular configuration graph. Those were things that came from specific roles. So it's done the same way here. In fact, all of the Solaris support is wrapped up into a very imaginatively named thing called the Solaris role. Okay? That's all the expertise is bottled up, meaning that you can take your Linux front end, add the Solaris role, and you get this functionality to go off and provision Solaris backends. Okay, we can build Solaris distributions. This was something that's actually quite difficult. It's not well documented. How do you pull apart and update a Solaris distribution and update it so that you can install against it? There are other utilities that need to be added to the mini root installation or just to the installation itself so that we can get some of the scalability aspects of ROX working. These are all hard. They're just roll up the sleeves and dedicate a person or two to work on it, and that's you get down to the the level of detail that you want. Right? There's an issue in terms of scalability with the way Solaris installs, is that it demands you to do NFS-based installations, right? NFS without lots and lots of dollars really doesn't scale very well. So all these things are captured in something called the Sol Linux role, right? If you wanted to go experiment with this, you need to talk to us. It's not publicly distributed. It's not nearly at the level of not nearly at the level of polish that we would let it out to the wild world yet, but we're getting there. And it provides support for generating Jumpstart files through the configuration graph. So now there's all the tools have been written so that as you put things in the configuration graph and you run through it the exact same way we generate a Kickstart file, we generate the set of Jumpstart files, right? There are the various preparatory scripts and finishing scripts and other sorts of things that need to be there, right? So when you integrate a Solaris appliance, it comes up, it just gets added. The role adds this ability to say, I want to build a Solaris backend node. And if you look at the things in here, it's processing the profile, and it's found some things that have come up that says rocks on it. So it's integrated. The rocks pieces have been integrated well and deeply into the distribution. And then finally, when it's doing installation, you see the various pieces, the various package things that are installed. So this is Anoop can show you this stuff in detail in the Sun booth, right? And give you a nice demo, of it. And we're done. Okay, so I'm going to stop. I'm going to stop here. And there were 2 slides, and we almost made it, but that's okay. Oh, he says that it's okay. So there were some things on Linux we can install packages using HTTP, and this is actually critical for scaling to thousands of nodes, right? And when we say scaling of thousands of nodes, we expect to be able to do 1,000 node installations in 20 to 30 minutes, right? Take the whole machine, take it down, and bring it up 1,000 nodes in about 30 minutes, right? And we use BitTorrent underneath to help us transfer that sort of thing. But in Solaris, we can't do the installations. Practically, we can't do it on anything other than NFS. And we know that NFS doesn't scale well without lots of dollars, right? And the mechanism in ROX is it's dollar-free. And what I mean by that is that it uses the infrastructure that's already there inside of your cluster. You don't add anything. You don't have to engineer it. You don't have to configure it. It just does what it's supposed to do. And we already have 2 people who are not anywhere close to UCSD that have gotten great scalability with that particular software. There are other pieces that need to come in. We like to be able to monitor our installation as it's going using VNC if possible, and using your Ethernet network to get to it, sort of to act like remote lights out. Although it doesn't come up until you've gotten to some level in the installation. And so there are lots of issues to worry about. How do we go into the installer? Do we have to change the installer? Do we have to change the mini root? And then there are issues about, well, all this work is being done on Solaris 10. When we move to Solaris 11, and it's a different installer, the Cayman installer, what do we actually do there? So now I will stop there and happily take any questions, but all real questions should go to those guys over there.
No questions? So Phil, thank you very much.
Yep.